What we have on the screen is the 6 Yagis, and we're looking at the ring. We're centered on the ring in the middle of the array. That's called a TIC rotor, T-I-C rotor. And the antenna rotates on the outside of the tower around that ring. There are 2 motors on the ring that actually turn the array. The array weighs about 650 pounds. Each antenna is 37.5 feet long. They're separated by 16 feet. There's 3 antennas high, 2 antennas wide, and we're elevated to about 20 degrees elevation. Now if we scan up the tower a little bit, there's the omnidirectional antennas, and this array of 6 has an antenna beam width of 3 to 5 degrees between the 1 dB points. Very, very critically sharp on aiming. Readouts I'm using, they're called absolute readouts by Digital Radio, I believe. And they give 1/10 of a degree accuracy for readout. On the very top of the tower are 4 what they call omnidirectional, horizontally polarized 2-meter antennas. They're called big wheels. Some people call them clover leafs. They're phased together with 1/2-inch heliacs and a 4-way power divider up on top. Each antenna is about 3 dB. So when you double your antenna array, you get another 3 dB. So from 1 big wheel to 2, you get 3 dB. So you started at 3. So you've added 3. So now you're at 6. When you double from 2 to 4, you get 3 dB more. So now we're at 9 dB. And the top big wheel is 126 feet off the ground. As feed lines go into the 100-foot tower, there are 2" and 5/8 heliacs that are connected to the 6 antennas, the 2 bays of 6, or the EME antenna, or the moon bounce antenna, whatever you want to refer to it as. So these are 2 inches in diameter outside diameter. They're called 1" and 5/8 heliacs. This is called 7/8" heliacs. Very low loss. These run 2 meters are rated at 2/10 of a dB per 100 feet. So I'm running roughly 200 feet. That's 4/10 of a dB loss. This bundle is all of the control lines going up to turn the antenna and rotate and elevate the antennas, as well as the readouts for where the antennas are being positioned.